Hey guys, this is Martin. We are in the SQL injection section, and today's lab is blind SQL injection with conditional errors. So it's once again a blind SQL injection, which means you don't get distinctive error codes and you don't get verbose message outputs. Blind SQL injections are some of the ones which are most common these days because frameworks simply got better and developers got smarter, but they exist. Okay, so this time around it's similar to the previous one, but this time we are dealing with conditional errors, with error messages. So in the previous one, we were dealing like with the welcome back message, which wasn't an error message, but this time we get a distinct error message. So to understand what this means is if I put the tracking ID cookie as XYZ, and then I put a quote, and then I get an error message. If I put two quotes, I do not get an error message. And that's basically the condition we are going to exploit. And you can then, for example, run a query like this, where you simply can then say from, not a real table, right? Like, which doesn't exist, and you should get an error in this scenario. And if you choose something like this, on the other side, like from users where row num equals 1, and if this table exists, then it will not return an error, basically, right? So this is how you basically exploit this, and then you work with the so-called case statements. So when you use the case statements, like for example here, select case when 1 equals 1, which is a true condition, then do a divide by 0, which results in an error. If the case is not 1 equal 1, but 1 equal 2, for example, then it will not throw an error because then it will not do the then statement afterwards. It will straight jump to the else, right? And so leveraging all this, you can then, for example, use the same conditions we have done before, or in the previous lab. You can then go in here and say, like, for example, when the length, select case when length of the password is greater than 1, then do a divide by 0. So basically, this is a true condition, but it will throw an error. So it's kind of an inverted logic, right? Like whenever you have a true condition, it is an error. When you have a false condition, it's not an error, right? Because it will only divide by 0 when the password is greater than 1. And then once again, you would run through, like, I encourage you to read all through all this. You would run through like all the different positions, and you can do this in burp intruder. So you would then simply track when you get a different response, and then you basically are at the level of the password length. And then from that on, you basically can use like a condition like this, like it's described here, where you then need to set the password, first of all, the character you are testing, and then also like the position, and then effectively you can run through this, and you want where username is administrator because you wanna get to the administrator password, and then basically it would look like this, where you then simply have a variable which you run through burp intruder in order to reiterate through all these different positions until you have like the first character A, B, C, D, E, F, G, and so forth. And then once you have the correct condition, then you jump to a second character, third, and so forth, depending on the password length. It's very, very time consuming to do it manually, but I encourage you to read through this manually to understand how it works. But in reality, you use SQL map, right? And so we just go here over to pets, for example, and then in there we can see there's basically two cookies which are set. One is the tracking ID and one is the session ID, so to speak. So those are our cookie values. And then we construct a simple SQL map command, SQL map -u for the URL. And then we can put anything in here, right? Like any category, it doesn't matter. The pets category is not necessarily vulnerable. It's not vulnerable in this case because the vulnerability, the blind SQL vulnerability, is in the tracking ID, in the cookie, or in this one here, right? But you need to add it, and then you say --level 2, and then basically you just run it. Like I already ran it. If you don't know the database you're up against, you simply leave this blank here at the end, and run it for the first time. So you uncover the database version, and then afterwards, once you know the database, you can basically run a command like this. So we are dealing with an Oracle database, and then we want to dump the database contents with 5 concurring threads. Okay, and once this is done, it looks like this. So once again, it runs through the whole thing, and then at some point it basically detects that the tracking ID appears to be vulnerable to Oracle and Boolean-based blind SQL injection. So it's injectable, so it gives you the error message and all that, and then it's actually going through this, and it takes quite a while sometimes because it's blind, so it has to go through all the different positions like what I just explained, but it's simply automating this for you, right? And at the end of the day, it will extract the administrator password, and I take this password, I hop over to my account, I log in with the administrator, and that should solve the lab. I hope this makes sense, and I see you in one of the next videos.